Hey, hello there. Welcome back. Long time no see. So we are already at December. In fact, in the middle of December of 2024. And that means Advent of Code is running, but I haven't even started with this year's puzzles. And I meant to do so, but things have been pretty hectic on December so far. But now things are a bit quieter, so maybe I can do some recreational programming today, and that's what I mean to do on this session. By the way, I have moved around, so I'm in my room now in a new place, and this new place has a lovely scenery, as you can see from my virtual background, which is a photo I took yesterday. So anyway, that's enough of a preamble, I guess. Let's jump to this year's Advent of Code and see what we have. Oh, look at that, already a bit of a spoiler. It looks like a number 10. I guess we are 10 years of Advent of Code? I have no idea. But let's start by the first challenge, which is Historian Hysteria. So I hope the font size, yeah, it's already bumped pretty much, so it should come clear in the video. Day 1, Historian Hysteria. I don't know how to pronounce Hysteria. The chief historian is always present for the Christmas slide launch, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. As each location is checked, they will mark it on the list with a star. They figure the chief historian must be on one of the first 50 places they look. So in order to save Christmas, you need to help them get 50 stars on their list before Santa takes off on December 25th. Okay. Collect stars by solving puzzles. The puzzles will be made available on each day of the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. You haven't even left yet, and the group of elvish senior historians has already hit a problem. Their list of locations to check is currently empty. Eventually, someone decides that the best place to check first would be the chief historian's office. It's been a while since I've read anything in English, so sorry for my rough pronunciation, but this is also meant as a practice for me. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Indeed, the elves discover an assortment of notes and list of historically significant locations. This is a mouthful to pronounce. Historically significant locations. This seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Oh, this was a question, of course. Perhaps these notes can be used to determine which location to check. Throughout the chief's office, the historically significant locations are listed not by a name, but by a unique number called location ID. To make sure they don't miss anything, the historians split in 2 groups, each searching the office and trying to create their own complete list of location IDs. Okay. There's just one problem. By holding the 2 lists up side by side, your puzzle inputs, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their list. For example, here is an example of the input. So these are basically 2 lists of numbers. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list. Then the second smallest number on the left with the second smallest. Okay. So we have to sort these 2 lists and then pair them up. Within each pair, figure out how far apart the 2 numbers are. You will need to add all of those distances. For example, if you pair up 3 from the left with a 7 from the right list, the distance apart is 4. If you pair up 9 with a 3, the distance apart is 6. In the example list above, the pairs and distances would be as follows. The smallest numbers in the left list is 1, and the smallest number in the right list is 3. The distance between them is 2. Okay, I wonder if there are negative distances. The distance is 1 with the second smallest. The distance is 0, distance of 1. The largest number in the left list is 4, with the largest number in the right list is 9. Okay, so the distances are always positive, it seems. To find out the total distance between the left list and the right list, add up the distances between all the numbers you found. In the example above, this is 2 plus 1, 0, 1, 2, 5, a total of 11. Your actual left and right list contain many locations IDs. What is the total distance between your lists? And the input is this, which is a giant list of numbers, which are not so big. All right. So I guess let's just jump into the code. Let's go to dev directory and create a advent of code 2024. Now this is a mixer. Sorry, it's been a while since I've done anything. So cd to advent of code 2024. And by the way, I'm of course going to solve this in Rust again. So cargo init, I guess. All right, and then just open this on the code editor and just remember how to do anything in Rust. Let's see if I can remember. So we have a hello world. I'm not going to worry about project structure or anything on this session. I just want to get the first puzzle solved. So what do we need to do to solve this? Let's start with sample actually, and copy this and just say that our input is this. Yeah, that's beautiful. And it's gonna be of type string slice. And what are we going to do with this? We need to parse numbers, and we need to split these two things into two lists, which should be easy enough. So we're going to take the input and do lines. Take the lines and we're going to parse. Let's remember how we used to do these things. First we do the parsing. Let's get all the numbers, and then we do the processing, I guess. So actually the parse thing would be like a left and right list, right? So yeah, let's think about this. We're going to go through each line, and then we're going to map these things. Oh, by the way, I can bump the font size, I guess, and close the side thingy. And then we're going to get each line and split once. Can we split by white space here? Or, yeah, there's a split white space. This is always split by 3 spaces, right? Also in the actual input. Yeah, let's just do split once and not think about this. So the delimiter is going to be 3 spaces, 1, 2, 3. Pretty horrible. And then we are going to split once should return an option. So let's extract this into a variable, and let's, yeah, this is let's remember, yeah, this gives us an option And we basically want to then parse this thing and propagate any errors up. So I think I'm going to I want to probably use anyhow. I will be using anyhow, so let's just cargo add this anyhow. All right, and then do a context expected to numbers and propagate this thing up. Then this should give us two things, right? Like the left and the right number. And then we're going to parse these two things. So we're going to do L parse and right parse. And we're going to return a tuple with these two things. And again, we're going to propagate up any errors. If I did this correctly, I should then collect the results of this, which like ignoring, or I guess propagating the results up. So for that, I also like to cargo add itertools, which is a very nice library for iterations or iterator helpers. So we should propagate this and then try collect and propagate everything up. And let's say these are the left and right lists of numbers, which should be of type. I need to define the type here or do a try collect and pass the type which I want to collect into, which should be like two vectors, I guess. So this will be of type vector of, let's just give it a type here for the numbers so it knows what to parse into. And look at that, it almost worked. So here, all right, almost there, I think. Yes. Why don't you like this? There should be a result. Well, I want to see something. The cargo Tomu. Oh, where's in the 2021 edition of Rust? Maybe I would like to use the 2024, which is, but it's not stable yet, so maybe I should just use stable. So maybe I tried too hard to make this very functional, and that was not the best approach. I should try to understand this, but it's been a while since I did Rust, so I'm a bit lost now. So what I wanted to do was to, oh, wait, this doesn't make sense. I'm mapping each line to a pair of numbers. So yeah, if we try to collect this is actually not going to, this doesn't make sense. We can say this should return like the numbers, which we can say it's a vector of tuples of this. But I was thinking a little bit more ahead. Let's see if this works now. It doesn't, but why not? Oh, this is propagating up. Let's make main return a anyhow result of Nothing. Right? Do I need to specify the error? Ooh. Oh no, it's not an. It should be a result of this and anyhow error, I guess. And finally we say OK. All right. We are getting somewhere. Oh, okay. This should be. We're propagating the errors here, but what we are returning is like a tuple. So we need to like wrap this in an OK, I think. Oh, and look at that! It's suddenly compiled. Oh no, almost there. Oh, look at that! That's a bit sad. Can we, if we add a context to this, like it doesn't matter, but let's, like, just to force this to be anyhow, like wrapped by anyhow errors, and always written like the same type, and we propagate this thing up. Not really. Now type annotations. Why does it need to annotate types here? I don't quite like this. I think I'm going to simplify this thing and just say let left and right be actually let left be a vector, and same thing with right numbers. And I think about doing it the functional way afterwards, but now let's just say for line in input lines, we are going to sort of do this. And instead of collecting, we're just going to push each thing into the separate lists. We have the left and right numbers. Oh, I said lint here, it should be line. Okay, now this propagation works. It goes like outside of main, and we should also be able to do left push and L parse and just propagate the error from parsing. Does this work? It doesn't, but it probably needs, yeah, it just needs type annotations. So let's also push this into the right list. Okay, so this code is actually simpler, and it should just work if we add a type here. Oops. All right, it does. All right, that was a lot of nonsense. Let's also print line the left and right things. Let's see if we got these things right. I think I need to do a debug print. All right, does this work? Cargo run. And I think it did. We have 3, 4, 2, 1, 3, 3. Yep, the left numbers and the right numbers. Okay, that took a lot of time. Just because I wanted to do, yeah, like the functional collection of things. I should probably get that working, but not right now. Let's just get to a solution. So we have the left and right numbers. Then we need to sort this lists. So let's do left sort. These are numbers, so they should be sorted, and then right sort. And then let's do the comparison. So what we want to do is to zip these two things, right? Like left zip, or I guess iterate it, and then zip it with the right numbers, and then we are going to get the comparison of the smallest with the small, like pairwise comparison, and then we just get the differences and we add all of them together. So if we do map, and we're going to have the, again, left and right numbers, we can do left minus right, get the differences, and then sum this together. I think this should be, let total diff be this, and let's just print it. So what do we get now? Oh, I forgot that the sum method is a bit generic, so you need to specify types of things. Minus 11, that doesn't seem right. So we wanted to see positive 11, and I think this is because we probably need to take the absolute value when we make the difference, right? So let's take the abs of this, and does this work now? It did. So it does work for the sample. Let's do something horrible and just copy all of the actual input into here. So we run it now, and is this the first answer? Yeah, all right. We got a golden star with a messy solution and a pretty failed start by trying to do very iterator kind of things, but we got the answer in the end by doing like a very how do you call this? Like procedural code of mutating and pushing things into vectors, which works really nicely. Okay, so let's now solve part 2 and maybe then think about improving things. So part 2. Your analysis only confirmed what everyone feared. The two lists of location IDs are indeed very different. Okay, yes, because the total difference was huge, right? It's a huge number. Or are they? The historians can't agree on which group made the mistakes or how to read most of the chief handwriting. But in the commotion, you notice an interesting detail. A lot of location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times the number appears in the right list. Here is the same example list again. Okay. So, sorry, what's calculate the total similarity score by adding up the number in the left list after multiplying it by, okay, the number of times it appears in the right list. The number of times it appears in the right list, okay. The first number in the left list is 3. It appears in the right list 3 times, so the similarity score increases by 3 times 3. Okay. So the second number is 4, and it appears 1 time, so it's 4 times 1. All right. So for this example list, the similarity score at the end of this process is 31. So yeah, it comes from this this calculation. Once again, consider your left and right list. What is their similarity score? Okay, let's go back then to the sample input and do this part 2. So this is the total difference, right? Yes, total distance, I guess. Let's call it distance. And now we're going to calculate the similarity score, which will be something kind of similar, I guess, but we're going to do something quite different. No, actually, we're not going to zip this. We're going to look at that. This is reference to an i64, and this is an i64 because we are consuming here. So I guess we can do an into. No, actually I don't want to consume it because we are going to iterate the left and the right again. So maybe I can pass. I'm already thinking in Rust, but not inter, iter. Okay, now for the similarity score, we want to iterate the left numbers and see how many times they appear on the right list. So to do that, what do? We have the left number, and we want to say, like, count the number of occurrences of that in the right list. Yeah, I guess we can. Do we have a nice way of doing that? Like, right, it's not a count, it's, well, we could do a, since we know that the right list is sorted, we could do like binary search, but that doesn't seem it doesn't seem worth it. We can do an iteration on the right list. The amount of noise that comes up when typing things in Rust with Rust Analyzer is a bit annoying. What we want to do, we want to iterate and count how many of these are basically the left number. So we can just say count, or no, I guess we can filter the right numbers that are equal to this left number and then count these things. All right, so here we have like a double reference. Let's a single reference this, and then we want to get this into a variable or just multiply this left number times this. And this is an i64 and this is use size, so let's just cast this. And this should be the similarity score, I think, unless I messed things up. So let's also print that. It's 31. Was 31 it? Yeah, for the sample it should be 31. So let's copy the actual input once again and substitute it here and run this thing again. And is this the answer for part 2? And it was. Okay, nice. So it's a horrible solution, but it is a solution nonetheless. So I think I'm pretty happy with this. I mean, I'm going to refactor it later, but maybe I can extract the input to a file, I guess. So yeah, let's just do that. Let's say new file, inputs, and this will be the input for day 1. Call it txt, and just paste, no, not the answer, but the input. All right, and then let main, what do we want main to do? Just read. Yeah, let's just do let input be include string of inputs. Can we do this? What's the error? Oh, okay, I have to go to the parent directory. Not very beautiful, but at least it lets me get rid of that giant constant. And let's call this thing input. And that should be it, I think. Actually, this could be a constant, but yeah, it's fine. Yeah, let's actually promote local to constant. Look at that. Look at that beauty. Oh, actually, I can leave it here. We have left and right numbers. We're sorting them and then doing this interesting calculation. I think it does look not too bad, I think. Maybe you can specify the types of these vectors here, which I think is a little bit nicer. And then remove this turbofish. Then we sort them and we calculate these two things, and that should be it. Yeah, this is not a very bad solution for day one. I'm going to refactor this and think about project structure later. But if we run this, cargo run again, we should get the same answers, yeah. Okay, let's do a git init here, and actually I should probably, oh, there's a git ignore. What does the git ignore look like? Oh, the target directory, that's nice. So let's actually add everything, right? So git add everything and commit this thing. Commit day one solution. Hacky day one solution. All right. I think that should be it for this video. Maybe actually I should give it a try to do this like the functional way with iterator combinators. Let's give it a try and see if we can figure it out. So what I wanted to do was to map this into the numbers, and then maybe we can like extract the parsing, and then like this will be like pairs of numbers, and then we want to do like the opposite of zipping, which would be unzipping, which I wonder, does Rust have an unzip? Oh, look at that. Does it come from itertools or from the Rust standard library, like unzip? Yeah, it's in, look at that, it's in the standard library. That's awesome. So how does unzip work? Converts an iterator of pairs into a pair of containers. Oh, so it's like collect, right? Yeah. Yeah, this is awesome. This is exactly what I wanted. You have a pairs of things, and then you unzip it and you get, yeah. This is what I want. So I don't know if I want to mix this with the parsing, because this like splitting of inputs and then converting things into numbers, it's like parsing related, and I don't know if I want to mix those two things up. So let's say parsing each line will, I can extract this thing into a function that parses each line and then just process that. So yeah, let's do this thing. Let's try this. Let's try to unzip a list of pairs, or an iterator of pairs. The thing is that unzipping probably won't like doing this in one go and doing the error propagation is going to be difficult, I think, unless there is also unzip multiple nested tuples. Multiple nested tuples. Oh, look at that. Wow, that's quite powerful, actually. It's interesting. Can we... Okay, let's do it step by step. So what I want to do is like say something like lines map into like a function that will parse this line, and then collect this thing into let pairs be this, and then inside this function that takes a line, I basically want to do this and not push things, but just have a tuple of two things, kind of what I was doing before, but let's do it step by step. No, not this. Let's drop it in an OK. All right, if we do this and then we try collect and propagate this thing up, I'm probably already getting like the same errors. Parse, let's specify what I want here. I want a vector of tuples of numbers. Okay, and this thing also wants to have the like how do you say, the type annotations, but if we extract this closure and convert closure to function, and yeah, let's just take it out of the main function and call this thing something sensible like parse line. This should be a result of anyhow error, and now it does propagate up, and now try collect doesn't work because this comes from Itertools. So let's try it again, and now it's importing Itertools and it should work. Okay, now we have the pairs. Okay, and this does all the parsing, right? And actually I shouldn't need to specify this type here, I think. Unless, no, I need to say I want to collect things into a vector at the very least. Okay, now we have the pairs, and now we can do left and right by unzipping, I think. So, but we still need to define them as mutable because then we need to sort them. So let's mute left and mute right. The pairs into Iterator. So we are collecting and then like converting into an iterator again. I would like to collect in one go, but and avoid this temporary, like intermediate vector, like do it just with iterators. But let's try it first to unzip here and see if this works. I probably need to annotate this, right? Yes. So insert explicit thingy, and we want a vector and another vector. And now it does work. And does it still cargo run? It still seems to print the same answers. So yeah, that was a nice, interesting refactor. I have never used unzip before, so this is a nice change. Let's add it, and let's see if we can get rid of this intermediate vector, because we should be able to like unzip, I think, this thing, or maybe no, maybe it can't unzip, because what's the type of this? Unzip takes an iterator where the items should be pairs. So we cannot accept items that are results. So can we get rid of those results? But you know, iterators are lazy, so maybe unzipping it's not possible here. That's yeah, that's unfortunate, I think. But on the other hand, maybe it's fine. Maybe it's fine. I think this is a little bit better than what we had before. And the total distance makes sense. Similarity score also sort of makes sense. I don't know if this is the best approach of counting the occurrences of something, but it's readable enough, I think. Yeah, I think this is a slight improvement. So let's commit this change and say use unzip to convert an iterator, to convert from pairs, from a list of pairs to two lists, right? Or just say use unzip and the change should be obvious. All right, so I think that was it for this session. I'm a bit rusty, as you can see. I haven't programmed in a while. So yeah, in later sessions I'll probably be doing newer puzzles and also giving some structure to this project. But I think that's been it for today. Oh, I almost forgot. I have to make a thumbnail for this video. And how did I do this? Using Toilet, I think. I don't remember when I used this, but if I say AoC 2024 day 1, how does this look? Oh, I remember now. It looks awesome. Can I increase the font size? Yes, I can. And this is day 1, and we are. Can I insert no, a new line here? Not with control, but with this. Okay. Unzipping, I guess, with Rust. And then pass this to lolcat. think this sounds a bit inappropriate, but it's fine. I think that will be, or no, let's say unzipping numbers with Rust. How do I insert a new line without messing things up? Does this work? Not really. Come on, fish, help me here. Unzipping numbers with Rust. And pass this to lolcat. All right. Yeah, that seems like a fun thumbnail. I think this will be all for today's video. If you have been, thanks for watching and see you later. Bye.